Section 6.1 Annuities. Most of us aren't able to put a large sum of money in a bank today. Instead, we save by depositing a smaller amount of money from each paycheck into the bank. This idea is called a savings annuity. This is how most retirement accounts work. In this course, we will assume that you put equal amounts of money into the account on the regular schedule. For example, it could be every month, every quarter, every year, and so on. And let it sit there earning interest. Suppose you start out by making monthly deposits of $100 into an account that earns 12% annual interest. We assume that the account is compounded with the same frequency as we make deposits unless stated otherwise. If payments are made monthly, we assume interest is compounded monthly. If payments are made annually, we assume interest is compounded annually. We will also assume in this course that all compounding and payments occur at the end of the month. We start out by making monthly deposit of $100 into an account that pays 12% annual interest. In this course, we assume that the account is compounded with the same frequency as we make deposits unless stated otherwise. So in this case, I deposit $100 into the account every month. So my interest should be compounded monthly. So 12% annual interest is equivalent to 1% monthly interest. Because there are 12 months a year, so I'll just take 12% divided by 12. In order to determine the monthly interest, you will take the annual interest divided by 12. Now, for example, if I am making quarterly deposits, then my interest will be compounded quarterly. I will take the annual interest divided by 4 because there are 4 quarters in a year. So let's take a look at this table. I have the month when I start depositing the money into my account, prior balance, the interest on the prior balance, monthly payment, and ending balance. So let's start up with the first 6 months. I have 1, 2, 3, 4, 5, 6. The reason why it's 1% interest because this is the monthly interest. My interest is compounded monthly. In this class, we will assume that all compounding and payments occur at the end of the month. So for the first month, I will start putting my money in at the end of the first month. Right now, my account has nothing until I put the money in for the first month. So the account balance before the first month is 0. And the interest on this balance is also 0 because 1% of 0 is 0. The monthly payment, which is the payment that I am contributing to my account this month, will be $100. And at the end of the first month, I will have $100 in my account. On the second month, the balance that I have before the second month is the balance that I have by the end of the first month, which is $100. The interest that I earn here will be the 1% interest on the prior balance. So it's going to be 1% of $100. So I'll take 0.01 times 100, that is $1. Now, at the end of the second month, I will contribute another $100. Now, this is the balance in my account at the end of the second month. How much is it going to be? So, at the end of the first month, I contributed $100, and this $100 earned me $1 in interest. And then at the end of the second month, I contributed in $100. How much do I have in total? 100 plus 1 plus 100, that is 201. At the end of the second month, I have total of $201 in my account, where $200 are my contribution and $1 is my interest. In the beginning of the third month, I have not made my contribution in yet, because remember, we assume that we make the contribution at the end of the month. So in the beginning of the third month, the prior balance I have here is the ending balance on my second month, which is 201. And in this column is the interest that I earned on the prior balance. So it's going to be 1% of 201. 0.01 times 201. And that gives me $2.01. At the end of the third month, I will contribute $100 in. After contributing the $100 for my third month, in my account, now I have $201 plus $2.01 plus $100, which is $303.01. Starting on the fourth month, my balance in the beginning of the fourth month is the ending balance of my third month, which is 303.01. And the interest for the prior balance is 1% of 303.01. 0.01 times 303.01. 0.01 times 303.01 equals, it is 3.0301. And because we are working in the amount of dollars, so I'm rounding it to 2 decimal places, which is 3.03. So the interest that I earned here is $3.03. At the end of the fourth month, I will make my contribution of $100. After I make the contribution, the total amount I have is 303.01 plus 3.03 plus 100. That is 406.04. In the beginning of my fifth month, the prior balance was 406.04. The interest that I'll earn is 1% of 406.04. 0.01 times 406.04. And I get $4.06. Again, we round to 2 decimal places here because we're working in the amount of dollars. At the end of the fifth month, I'll make a contribution of $100. And the balance that I have here is 406.04 plus 4.06 plus $100. That is 510.10. So $510.10. In the beginning of my sixth month, the prior balance was $510.10. The interest will be 1% of 510.10. So I'll take 0.01 times 510.10. and I get $5.10. Again, round to two decimal places because we're working with money. At the end of the 6th month, I'll contribute another $100 in. After I contributed my $100 in the account, I have 510.10 plus $5.10 plus $100, which is $615.20. After 6 months, you have contributed the total of $600 because you have contributed $100 each month. But in your account, you have total of $615.20. So $600 is your contribution and $15.20 is your interest because you earn interest every month. This is the table for the first 6 months. But imagine if you have the account for 20 years or 30 years. We will not have a table for 20 years or 30 years. So we're going to come up with the annuity formula. My annuity formula is A equals PMT times 1 plus R over N, the whole thing raised to N times T, and then minus 1, all over R divided by N, where A is the amount in the account after T years. PMT is the regular deposit, the amount of money that we contribute each month, each quarter, or each year, and so on. R is the annual interest rate, which is the APR. N is the number of compounding periods in 1 year. And T is the number of years we plan to make deposits. In Chapter 5, we learned how to calculate the compound interest, so we had the compound interest formula. In this section, we learned how to calculate the annuity, and we have the annuity formula. The question is, how do I know when to use a compound interest formula and when to use the annuity formula? Both annuity and compound interest formulas serve to calculate compound interest. The disparity lies in how contributions are made to the account. When numerous regular deposits are made, the annuity formula is used. Conversely, when a single deposit is made, the compound interest formula is used. Compound interest is used if one deposit is made. Annuity formula is used if many deposits are made. Example, a traditional individual retirement account, IRA, is a special type of retirement account in which the money you invest is exempt from income taxes until you withdraw it. If Charlotte deposits $100 each month into an IRA, earning 6% interest, how much will she have in the account after 20 years? Charlotte has an account that's called an IRA. She deposits $100 into the account each month, and the account earnings 6% interest. They're asking how much she'll have in the account after 20 years. This account is earning the interest for 20 years. How do I know if I should use the compound interest formula or the annuity formula? Well, I need to look at how the contribution is made. If the contribution is made in one deposit, then I will use the compound interest formula. If the contribution is made with many deposits, then I am going to use the annuity formula. So in this case, Charlotte deposits $100 each month for 20 years. So from now to 20 years later, she will deposit $100 each month to her account. So in this case, Charlotte is making many deposits into the account, so I am going to use the annuity formula. This is my annuity formula. A is the amount of money that I have in total after 20 years. So A is what I am looking for. PMT is the amount of money that I deposit each month, which is $100 here. R is my annual interest rate. In this case, that is 6%. And when I'm using the annual interest rate in my calculation, I will need to turn this into a decimal. So 6% is equivalent to 0.06. I take 6 divided by 100. N is the number of compounding periods in 1 year. In this case, Charlotte is making monthly deposit. So we assume that the interest is also compounded monthly. So N is 12. T is the number of years that we plan to have the money in the account. In this case, that is 20 years. So I am substituting PMT with 100, R with 0.06, N with 12, and T with 20. So I have 100 times 1 plus 0.06 divided by 12, the whole thing, raised to 12 times 20, minus 1. And this whole entire thing is divided by 0.06 over 12. First, I'll take 0.06 divided by 12. I'll have 0.005. So I am replacing this fraction with 0.005 and this fraction with 0.005. And I also simplifying 12 times 20. 12 times 20 is 240. So I replace that with 240. Next, I'll take 1 plus 0.005. That makes it 1.005. And then I'll put this whole fraction in a calculator to get to my answer. So I will take 1.005 raised to 240 first, and then minus 1, and then take that, multiply by 100, and then take that divided by 0.005. 1.005 raised to 240 equals minus 1 equals. So this is the number that inside the bracket. Now I take this number times 100. This is the number in the numerator. Now I take this number divided by 0.005. I get 46204.089561. The question does not give me any rounding instruction. However, we are working with dollars, so we are going to round it to 2 decimal places. This digit is 9. I will round up to 46204.09. If Charlotte deposits $100 each month into her IRA, earning 6% interest, after 20 years, she'll have $46,204.09 in her account. Next example, you want to have $200,000 in your account when you retire in 30 years. Your retirement account earns 8% interest. How much do you need to deposit each month to meet your requirement goal? So I want to retire in 30 years. And when I retire in 30 years, I want to have $200,000 in my account. And my retirement account is paying me 8% interest each year. The question is, how much do I need to deposit each month in order to have $200,000 in the account when I retire? Again, trying to see if we should use the compound interest formula or the annuity formula. In this case, they're asking how much do I need to deposit each month for 30 years. So I'm making many deposits here. So I'm using the annuity formula. This is my annuity formula. A is the amount of money I have in my account after 30 years. That means A is $200,000. This is what I want to have in my account after 30 years. A is $200,000. PMT is the amount of my regular deposit. In this case, is my monthly deposit. How much do I deposit each month? I don't know. That's what they're asking. So I'm looking for PMT here. R is my annual interest rate. In this case, that's 8%. And I am converting 8% to a decimal, which is 0.08. N is the number of compounding periods in 1 year. In this case, they're asking for my monthly deposit. So my interest will also be compounding monthly. So N is 12. T is the number of years that I plan to have my money in the account. In this case, that is 30 years. So T is 30. So I am substituting A with 200,000, R with 0.08, N with 12, and T with 30. Next, I will need to take 0.08 divided by 12, 0.08 divided by 12, and also 12 times 30. 0.08 divided by 12. I have 0.0066666666. This digit 6 will keep continue forever. Now, I am in the middle of my calculation. I'm not at my last step yet, so please do not round your answer here. Carry as many digits as you can. Because if you round to 2 decimal places here or 3 decimal places here, your answer will be off. So I'll carry at least 8 or 9 digits. This fraction, 0.08 over 12, is going to be substituted with 0.00666667. And 12 times 30 is 360. I want to solve for PMT. That means I want to get rid of this number. I want to get rid of this bracket here. So the first thing I'm going to do is get rid of this number 0.006667 by multiplying both sides by this number. I take 0.006667 times 200,000. So instead of using 0.006667 times 200,000, I just use the result that I have in my calculator earlier by taking 0.08 divided by 12 And I just take this number multiplying by 200,000 and I get 1,333.33333. So this is not my final answer yet. So I will keep carrying as many digits as I have to. I'm replacing this product by 1,333.33333 equals PMT bracket. And here, I'll take 1 plus 0.006667, which is 1.006667 raised to 360 minus 1, close bracket. From here, I'll just simplify this. I'll take 1.006667 raised to 360 and then minus 1. So I take 1.006667 raised to 360 equals and minus 1 equals. I have 9.93703333215. Again, this is not your last step, so please do not round your answer here. You still need to use this number for further calculation, so please use at least 6 or 7 digits. So this whole bracket is replaced with 9.9370333, and that is multiplying by PMT equals to 1333.33333. And to solve for PMT, I'll divide both sides by this number. And this number got canceled out. PMT is equal to 1333.3333 divided by 9.9370333. 1333.33333 divided by 9.9370333. I got 134.178208903. So PMT is equal to 134.178208903. The question does not have any rounding instruction, but we're working with dollars, so we round it to 2 decimal places. This digit is 8, so I round it up to $134.18. If I want to retire in 30 years, and I want to have $200,000 when I retired, and my account is paying 8% interest, then I will need to deposit $134.18 each month for 30 years. Example, if you want to end up with $30,000 after 5 years in an account earning 5.2% interest compounded monthly, how much is your monthly deposit? I have an account that is earning 5.2% interest compounded monthly. I want to have it for 5 years, and I want to have $30,000 after 5 years. How much should I deposit monthly? Okay, so again, this is also compounding interest. So how do I know when to use the compound interest formula and when to use the annuity formula? In this particular problem, I need to make monthly deposit for 5 years. That means I have to make many deposits for the period of 5 years. So when you are making many deposits, that tells you you need to use the annuity formula. This is my annuity formula. A is the amount of money that I have in my account after 5 years. So in this case, A is 30,000 because I want to have $30,000 after 5 years. PMT is the amount of regular deposit. Do I know how much I need to deposit into my account each month? No, I don't. That's the question. So my PMT is what I'm looking for. R is the annual interest rate that my account earns. In this case, that is 5.2%. And that is equivalent to 0.052. N is the number of compounding periods in 1 year. In this case, it's compounded monthly, so N is 12. T is the number of years that I plan to have the money in the account. In this case, that is 5. I'm substituting 30,000 in for A, 0.052 in for R, 12 in for N, and 5 in for T. And I need to solve for PMT. Next, I need to simplify this fraction. So I take 0.052 divided by 12. 0.052 divided by 12. Again, do not round at this step. Do not round to 2 decimal places or 4 decimal places. Use this number and use as many digits as you see here, or at least 6 or 7 digits. So I'm going to use 0.0043333. So I replace this fraction with 0.0043333, and I also take 12 times 5, that is 60, and I put it here. So I replace 12 times 5 with 60. I need to solve for PMT. So I need to get rid of this denominator. So I'm going to multiply both sides by 0.00433333. So this number got canceled out. And I take 0.00433333 times 30,000. So I take this number times 30,000. That is 130. So this product is replaced with 130 equals PMT. I take 1 plus 0.00433333, which is 1.00433333 raised to the 60 minus 1. Then I'll simplify this bracket. I'll take 1.00433333 raised to the 60 and then take that number minus 1. 1.00433333 raised to 60 equals minus 1. I've replaced this whole bracket by 0.296201,53295. And that is multiplied by PMT equals to 130. And to solve for PMT, I'll divide both sides by this number. And this got canceled out. My PMT will be 130 divided by this number. 130 divided by 0.296201. 29620153 equals. The answer is 438.89036,868. The question does not give me any routing instruction, but we're working with dollars, so we round it to two decimal places. This digit is 0, so I round down to $438.89. If my account is earning 5.2% interest compounded monthly, and I want to have the account for 5 years, and I want $30,000 after 5 years, then each month I need to deposit $438.89 into the account.